Hi there. Welcome to the first of a two-part tutorial where I show you how to create a fully procedural city in Blender using geometry nodes. I like to keep things organized from the start, so let me create some collections and give them proper names. Now I'm going to add a plane and extrude its edge twice along the x-axis. This mesh is the starting point of a single city block. To add some buildings to this block, I'm going to add a geometry node modifier to it and switch to the geometry nodes viewport. Now, to understand the concept of geometry nodes, it helps to look at this viewport as a factory with an assembly line that moves from left to right. This assembly line takes an input and procedurally converts it to the desired output by modifying it along the way. In our case, the input is the plane mesh I created earlier, and the desired output is a city block that contains buildings with different shapes and sizes. An easy way I can demonstrate this concept of an assembly line is to add a node called pointInstance. What this node does is that it takes the input geometry and places an object of our choice on each of the vertices of that input geometry. So if I select the default cube as the instancing object of this node and then place this node in the assembly line, we immediately see that instead of the 8 vertices that we originally had, we now have 8 instances of the default cube. At this point, we have a single city block with 8 buildings in it. However, all the buildings look the same, and this is not what we want. We want to have some variation among the buildings, and specifically, we want our buildings to have different heights. We can make this happen by adding more geometry nodes. In the case we have here, where we want to create buildings that are different in size, we are specifically interested in the scale attribute of our geometry, and we want to randomize the scale attribute along the x, y, and z axes. So I'm going to add a node called the attribute randomize node and place it in our assembly line and configure it like this. Okay, so at this point we have some randomized buildings. However, this is just a single block and not exactly a city. To make this a city, I'm going to add some array modifiers. And make sure that these array modifiers are placed before the geometry nodes modifier. Now at this point, we can go ahead and add some detail to our buildings simply by editing the default cube. I can either do this by directly editing its mesh or by using non-destructive Boolean modifiers. The choice is up to you. However, I personally prefer to take the non-destructive route because it makes it easier to make changes in the future. Now, I am not limited to only having a single type of building. I can actually have multiple types by adding more objects to the building's collection. I can then tell the point instant geometry node to use any of the buildings inside this collection. However, one problem is that all the buildings are facing the same direction. I can fix this by randomizing the rotation attribute of the geometry, specifically the rotation about the z-axis. To do this, I use an attribute randomize node that rotates the geometry only about the z-axis by some amount ranging between 0 and 2 pi radians, or 6.28. And to have this rotation at fixed steps of 90 degrees, I use a node called attribute map range and set the mapping to be a stepped linear function. Now, I want my city to have a central business district, or a CBD, where the buildings closer to the CBD are taller than other buildings. To do this, I will create a new collection called CBD and add a single vertex to it. Then I will go back to the geometry nodes graph and add a special node called the attribute proximity node. This proximity node, along with an object info node, allows me to calculate the distance between a building and the CBD vertex. On the attribute proximity node, make sure to change the setting from faces to points, and on the object info node, make sure to change the setting from original to relative. I can then construct a new scaling vector by using an attribute map range node and an attribute combine XYZ node. Finally, I can combine this new scaling vector and the randomized scaling vector from before by multiplying them using an attribute vector math node. Now, the tallness of the CBD buildings and the size of the CBD area can be modified through the geometry nodes. and the location of the CBD can be changed by moving the CBD vertex. And as a bonus tip, I will now show you how you can have multiple business districts in your city. This was the first part of a two-part tutorial I'm creating on procedural cities and geometry nodes. In the second part, I will show you how to add procedural materials to your city. So don't forget to subscribe to be notified when the second part comes out. And that's it for this video. As always, thank you for watching, and until next time, take care.